have a lot of wealth of information to speak to here. Why don't we go ahead? Maybe James, start with you.
Hello, I'm James Hunt from Aicas. We're a company focused on edge computing. We've been in the industrial automation market for more than 15 years, and in the automotive market for more than 10 years. We have more than 50 million licenses for our platform in automotive alone. And our focus is to bring IT technology to OT so that all the advantages that you have in the IT market can be used for OT programming, and the programmer can focus on getting the job done, not on twiddling bits.
Great. David Nelson from the Boeing Company, Chief Strategist for Cloud and Industrial IoT, and I also support autonomy across the company. And then we're a part of the Industrial Internet Consortium, where I'm chair of the Innovation Task Group on the User Council. So a lot of the work within Boeing, we focus on three main areas around industrial IoT, the smart connected factory, the smart airplane flyaway, and the smart supply chain.
Hi everyone, I'm Sam Nagar, CEO of Pixeom. We brand ourselves as software-defined edge. We're kind of a later stage startup here in Silicon Valley, about 100 people, and we basically deliver a virtualization layer that, once installed, makes it very simple to manage distributed and disparate infrastructure, which makes it match the cloud and offer the same services, same APIs as the public clouds out there too.
Hi everybody, I'm Christos, Principal Research Scientist with Orange in our office in San Francisco. Orange is France Telecom, for those of you who haven't heard of us before. And our role here in being the Valley is essentially scout like emerging technologies and working with startups. And I've been involved in SDN since like 2009, 2010, and then later on network function visualization. And nowadays I'm working on edge computing and IoT as well.
And I'm Aaron Allsbrook. I'm the CTO at ClearBlade. We are enterprise IoT software. It's pretty vague compared to what we all know it here, right? So what we really provide is the ability to build an IoT solution that integrates with all the assets you really have out in the field, right? So you're not having to put in new things, communicate with systems that you've got. And really take those existing assets and get them up to scale, get the security around them. Unique to us, or it's unique, is we can run on any cloud, run on-prem, or the full stack at the edge. So we provide a lot of value to folks trying to build and change and grow their solutions.
Great, thanks guys. So what we want to kick off with is to start to talk about latency and the value of different locations in the edge. And how we think about that in terms of determining where you're going to process your data and what you want to do with it. So, James, would you mind starting us off with how you think about the impact of latency on your IoT solutions and where you choose to process data, and how this decision to process data at the collection point versus other options that you might have?
Certainly. So latency is, of course, a big issue. For instance, we have one customer that uses our platform for monitoring thread in the spinning process, and where the thread is poor, actually stopping the machine, resplicing the thread, and keep going, so that we provide a higher quality product from a somewhat poorer material. So therefore, bring real value to his customers. Now the latency is there. He has to make decisions within 1 millisecond. You're never going to do that over the network. You have to do that kind of thing locally. There are other applications that you get away with doing things in the cloud. If you're, monitoring the temperature of a room and controlling heating, you don't have such deadlines. But then you have to ask yourself other questions about the wisdom of doing things, doing control applications from a cloud. Is it really necessary? What can happen if somebody provides a denial of service attack to the system and you can't make that connection? The fact of the matter is, any kind of networking is not, you can't guarantee that it's always there. So there's other issues that we have to think about not just the latency. Sending real-time data over the network is probably the most expensive way to do it. If you want to capture all data, it makes much more sense to do some local processing that's time critical, and then store and forward the bulk of the data so that you can compress it, you can take advantage of bandwidth. So latency is an issue, but so is security and also updatability.
Yeah, those are great points. Aaron, when you're thinking of software-defined IoT and some of the elements that come together with that, if we're staying on the topic of selecting locations in the edge, how do you think about where you would choose to put compute resources at or near the collection point versus elsewhere in the edge, aggregation, or back in the cloud?
Yeah, actually, so I was on a panel earlier this week, and we just started with what the heck is the edge, right? Because you can watch a commercial now on Sunday, and one commercial will tell you it's one thing, and then the next sporting event will come on the edge will have a totally different definition. So really the conclusion we came to is it's everything that wasn't the cloud or in a back office IT server, right? It's all now the edge. And ultimately what that means is we're going to have layers of edge, continuum of edge. And ultimately that then means if we have all these spots along the way where for latency we need to answer questions here, there, and yonder, how do we decide when we're going to do the processing? And there's I forget the point in time when this happened, but they started this idea of data gravity. And really the processing moves to where the data might be, right? So we saw a lot of stuff move to the cloud when we went down this data lake idea, and the processing moved there next to it. Now that we need stuff to happen where the data is, whether it's in the factory or whether it's in the interstate or by this co-location, right? That's really what's going to drive when the edge compute happens. Yes, there's value prop in durability if the network goes down. Yes, there's value prop in saving money. There's value prop in being able to secure it and bundle it safely. But ultimately, you're going to do that edge processing where that data is acquired. You're parking your car in a garage, it'd be great for your car to do its own processing to manage its air conditioning, right? You don't want to go to the cloud to turn the air on from your phone. But if you want to pay the bill, you got to talk at the parking garage level, right? You imagine a world where we have edges all the way along. You don't need to go to the cloud to pay the parking fee. But then as you get into traffic, well, where's the traffic data come from? Today, it's going all to some big cloud and coming back. But if you were to get that in the edge model, here you would be sitting right there on the interstate talking as you move along, maybe the cell phone tower, 5G antennas, whatever it is. So this edge compute's going to move up and down. It's going to be done where the data is available most efficient.
Great, well, and thank you for that. And I think it actually segues pretty well with the next question, which is about programs. So if we're talking about the federation of all these things, the next question is how do we manage that and what are some of the protocols? So David, maybe could you talk a bit about what protocols you see being key to edge processing and how you think about the impact of protocols on where you're choosing to process data?
Yeah, sure. And I think earlier we talked, there's not one protocol that rules them all, right? And there's a breadth of them, right? So we've got, all the way from infrastructure, we've got where I kind of live in the data side, so message queuing, we've got transport, so it really is the right protocol for the right use case. And then, at the Boeing company, we talked about, we've got supply chain, right? So I need location services both inside, outside, right? So GPS and non-GPS work together. Inside the factory, right? A lot of the data, we've had MQTT for 20 years now, right? AMQP, OPCUA, at the Industrial Internet Consortium in Raleigh, we spent a whole day with a workshop with the OPC Foundation. So, it just depends on which layer you're in, but you need to use the right protocols for the right situation. So, low energy is key when we're actually moving light away from the smart plant. We only have so much power, 50-watt bays and EV bays. So, it's a challenge.
Yeah, absolutely. And Sam, I know protocols can mean a lot. So I think David kind of brought us into this, where it's between the wireless and transmission protocols and different stacks. So. Can you talk a little bit about what do you see happening, particularly with the transmission protocols, and how does that play into where you're choosing to process data?
Yeah, absolutely. So I remember actually my first IoT World was 2015, and back then it felt like there were so many protocols, and there's a lot of different ones that have differentiated themselves in different ways. And what we tend to find, at least in our experience at the company, is there's a lot of, at least, desire to start consolidating and start across the layers that were mentioned earlier. And so we see like a lot of great opportunities, especially like I know in Jason's last talk before this, some of the great players in the space that are doing protocol translation across like OPC-UA, botnet, Modbus, a lot of these different layers, and they're being able to carve out very big opportunities for them because I think a lot of the trend back then was to go kind of top down when defining protocols and building out a lot of these. Some of them have been around a long time, but now that a lot of people start to realize that it needs to work for the factory worker who's on premise, right? And they need to be able to use this. We're seeing not just consolidation, but now also focus on to build off of James, to focus on securing that and hardening it and making it these protocols actually scalable and usable. And now that the market's evolved here too.
Yeah, absolutely, that's great. So why don't we shift gears and talk a little bit about some vertical examples. And Aaron, maybe you could start us off with a vertical example of processing at the collection point from your experience.
Yeah, in the edge, it's got a lot of technical reasons, right? There's reasons why we're all doing different verticals, and there's a lot of technical reasons why, whether it's speed, latency, hardness, but it only gets real when you apply a vertical to it. Lots of industries are going to use edge when it's all said and done. What I'm seeing right now, what we're seeing is use cases or case studies at this point where safety is involved really, really drive and can get things started quickly, right? I'm sure Boeing and you guys have lots of use cases, but if you can save a life along the way, everybody's on board, right? So rail is a great example. We're doing railroad crossings. We have them across Texas and right now and others going out. Monitoring a railroad crossing, right? You think about what happens today. Someone has to go out there and check to make sure those lights and those arms are going up and down. Roll a truck every week, there's cost with that. It's happening once a week or it's happening once a month. It's happening in all the countries around the world, all the states in the US. That's cost, but also the consequence of someone inspecting it on Sunday, not working on Monday and having 7 days of outage, that costs lives, right? 3% of Tier 1 freight rail in the U.S. budget goes purely to liability, right? Just straight off the bat, the value of human life and costs associated with that drives these use cases today. We see the same thing lighting up mines, just tracking vehicles, make sure they don't run over workers or run over pedestrians, right? We have those same solutions going right now, driving the edge today, first right out of the gate.
Right. And Christos, as the telecom representative of our group, maybe you can talk a little bit about where you're seeing a couple different verticals choosing to process data at or near the collection point versus leveraging more of the M2M and other connectivity to pull it back to deeper in the edge or into the cloud.
Right. So from our perspective, obviously IoT is one vertical, and within that that vertical there are also other sub-verticals, if you like, whether it's like smart buildings, smart cities, agriculture, or and then you have other use cases which are like more telco friendly or telco-oriented type use cases, has to do anything with using your phone. So that could be gaming, could be AR, VR, could be other, could be video, for instance, mobile video, or it's like 4K maybe in the future. And but from our perspective, the collection point doesn't have to be exactly the same as the edge, right? Now, ideally, you like that collection point on the edge to be where the collection point is. And it would vary from vertical to vertical. So if you're looking at smart buildings, obviously, that collection point is going to be at the building itself, right? If it's going to be AR, VR, or gaming, that's perhaps going to be the base station. So we're going to be able to differentiate depending on the use case and depending also the requirements. Right? You need some fast response. Obviously, collection point, that's where you do your filtering. You may have to discard certain data sets, and then hopefully, you'll be able to, if there's a device or an IoT that requires some response, you should be able to, process that and provide the response. And so that's where we're going to see that playing out. Now you may think, well, I mean, if it's like small buildings, what's the role of the telco? We don't know yet. I mean, there might be some role for telcos to play if they want to manage this kind of, environment for small buildings, or it could be, third parties that they have to, partner with. We'll see how this one's going to play out.
And James, I know Aicas is doing a lot in the automotive sector, as we've talked about. Maybe could you give us an example there from another vertical that you're thinking about from your experience? Sorry, how either the automotive vertical is processing data at the edge at the collection point, or
Yeah, so the data collection in the automotive industry is changing actually as cars progress. We put a platform out there for the Fiat Chrysler automobiles where you could download code to the platform after the fact, and they use that to experiment with what things they can collect from the car and use that to improve their maintenance. And actually, some funny things happen, like they found a lost car in their fleet because by putting new software remotely onto the car, they had a new capability, and they could use that to locate and keep track of where all their cars were. So as autonomous driving comes in, of course, you'll expect to do more of this local processing. So object recognition is a really good example of something that people want to do for ADAS systems and even for full autonomy. But the thing is, those systems they become better over time, and you want to be able to update the cars in the field, because if you can't, then you have a bunch of cars running around with old software. And that'll get to be at some point negligence, not just, it's not nice, but it'll be negligence, because there may be something in there that causes trouble under certain circumstances that you realize later. And you want to be able to update that system. Of course, once you can update, you have to understand what versions of the software are on the system, and which ones interplay and which ones don't, so that when you do the updates, you know what to change.
Yeah, that's a great point, that version management becomes kind of federated throughout the system of systems that are all interconnecting, and how you manage that. So that's fascinating. I know from personal, I had a rental car recently, Ford, that I pulled up and kept asking me to connect to Wi-Fi to update the car. So I think we're already seeing some of that, and hopefully they figure that one out so that it's a little more seamless in the future. David, from your background with aircraft, I think these are particularly interesting. One thing that we found in our own research was that I believe it was the 777 engines were generating a terabyte of data per hour per engine. Right? So of course you can't backhaul that off of a cellular network or a Wi-Fi network, let alone off of an aircraft in the sky. Right. So how do you think about what you're processing there, what you're just taking in and kind of leaving on the cutting room floor, and what you're pulling back to the cloud? How do you make those kinds of decisions?
A lot of that is what we describe as digital exhaust. So there's a lot that just can't, the volume is just too great to process, right? So, that's where we're looking. I think we may talk a little bit about some of the things we can see with 5G and the speeds, but there's a whole infrastructure that would need to happen, not only in the factory, but we have to light up the airports,